All right, so today we have notes 2A.1. So we're going to identify linear, exponential, and continuous versus discrete. So let's start with identifying if it represents something continuous or discrete. So we're going to do this side of our situations together. So remember from the other day, discrete is countable and the graph has dots, and discrete is also recursive equations. Continuous is measurable, it's explicit equations, and we have connected dots. Linear relationships are arithmetic straight line graphs. Exponential relationships are geometric or curved graphs. So let's start with discrete and continuous. So remember, discrete is you count, continuous is you measure. So weight of watermelons, well, we can measure weight, so that is going to be continuous. Green M&Ms in a package, we count that, so that's going to be discrete. Acceleration of a car. Your car, you cannot count the acceleration. You measure acceleration. So that's going to be continuous. Children per family. Do you measure that or do you count that? You count that, so it's discrete. The amount of pop that you drink. Can you measure that or can you count that? You can actually measure that, right? You can take some sips of pop. If it would have said the number of pop you drink, then that would have been countable because you count the number of pops you drink. Okay, next up we're gonna do, let's see, 1, 2, and 3 together. So we have to also identify if it's discrete or continuous, as well as linear, exponential, or neither. And we're gonna talk about why we get which ones we get, okay? So this first one, is this linear, exponential, or neither? It's linear because it's a straight line. Is this continuous or is this discrete? It's continuous because it's a connected line. All right, so next up we have days and peppers. So we have second day, 5th day, 8th day, 11th day, then we have 4 peppers, 5 peppers, 6 peppers, 7 peppers. So is this linear, exponential, or neither? Well, if we're given a table, we gotta figure out some mathy stuff. So we go 4, 5, 6, 7. So that means we're adding by ones on this side, and then we have 2, 5, 8, 11, and we're adding by 3 on this side. So if we're doing a bunch of adding, is that gonna be linear, exponential, or neither? It's gonna be linear because we are adding. And then peppers. Is that continuous or discrete? Do we count that? Do we measure that? It's discrete because we count that. And lastly, number 3. So we have f of x equals 2x minus 7. Is this linear, exponential, or neither? It's linear because it's arithmetic. And another way you know it's got a regular sized variable. So that also means it's linear, right? Linear is arithmetic. Arithmetics only had regular sized variables. Now, is this going to be continuous or is this going to be discrete? It's going to be continuous because it's an explicit equation. Once I'm done going through in class, make sure you do your exit ticket and finish up your video.